Hello student, now we have to discuss about geography paper second, that is 102 physical geography atmosphere. Now we have to study about unit number 4, humidity and applications of climatology. In this unit there are 5 sub-units. These are definition and types of humidity, forms of condensation, forms of precipitation, types of rainfall, applications of climatology in the fields of agriculture, settlement, health, trade and transport. Now we have to discuss about definition of humidity. The amount of water vapor present in the air at a particular time and space is called humidity. The term humidity is applied to the presence of moisture in the atmosphere. In the atmosphere, water vapor is invisible gaseous form of water. Atmosphere picks up moisture from different sources on the Earth's surface. Heat is applied to moisture evaporate it, that is, convert it into vapor. Water vapor is a highly variable constituent of the atmosphere and may form as much as 4% to 5% of the volume of atmosphere. The largest source of moisture to atmosphere is the ocean. The water vapor in the air is chiefly supplied by evaporation from the surface of the ocean, rivers, lakes, ponds, vegetation cover, etc. The water vapor is everywhere diffused through the air. Plants give off more moisture to the atmosphere. The conditions of atmosphere as regard to moisture are the capacity of the air for water vapor depends very largely upon its temperature. Then the movement of air which accelerates the rate of evaporation. Then the condition is the presence of water surface. Then types of humidity. There are absolute, specific and relative types of humidity. And now we have to discuss about absolute humidity. Absolute humidity refers to the weight of water vapor per unit volume of air. The actual amount of moisture present in the atmosphere at any time is called absolute humidity. The absolute humidity is expressed in grams per cubic meter. A mass of air of a given temperature and pressure can hold vapor up to a certain limited amount. When this limit is reached, the air is said saturated. The absolute humidity of the air is always more in the lower altitudes and it decreases with the increasing elevation because evaporation takes place on the surface of the earth. The absolute humidity is always more in the coastal areas than the interior parts of the continents, and always more over the oceans than over the land masses. Then specific humidity. The actual quantity of moisture present is denoted by specific humidity. Specific humidity is defined as the mass of water vapor in grams contained in a kilogram of air. For any special air temperature, there is a maximum mass of water vapor that a kilogram of air can hold. Specific humidity is often used to describe the moisture characteristics of a large mass of air. For example, extremely cold, dry air over Arctic region in winter may have a specific humidity as low as 0.2 grams per kilogram, whereas extremely warm moist air of equatorial regions often holds as much as 15 to 18 grams per kilogram. Then relative humidity. The term relative humidity is used to represent the proportion of water vapor in the air in relation to the maximum amount which the air can contain at a given temperature. It is expressed in percentage. There is an inverse relationship between temperature of air and relative humidity. That is, the relative humidity decreases with increasing temperature and vice versa. When absolute humidity and humidity capacity of the air are the same, the air is said to be saturated and relative humidity becomes 100%. Relative humidity of air changes according to the season and the time of the day. Between 30 degree north and 30 degree south latitudes, relative humidity is higher in summer than in winter. The daily variations in relative humidity also depends on the temperature of the air, and hence it is more in the early morning and is a minimum in the afternoon. The relative humidity is measured in percentage. It forms of condensation. Condensation appear in various forms. For example, fog, clouds, frost, dew, etc. are the result of condensation of water vapor. The process by which a substance changes from vapor to liquid state or solid state is the condensation of a water vapor. In the atmosphere, condensation results from loss of heat. Uh, the forms of condensation uh, includes fog. Fog occurs when condensation of water droplets together with particles of smoke and dust held in suspension. Radiation fog, advection fog, frontal fog, stem fog, and hill fog, etc. forms of fog are there. Then dew. Dew is formed by the air mass condensing on a solid surface of the earth. At night, surface of the earth cool down due to radiation. The result is that the cool air deposits its moisture on the objects that have cooled in the form of dew. The moisture deposited on the surface or blades of grass and leaves of plants are known as dew. The favorable conditions for occurrence of dew are long winter night, some amount of water vapor, calm weather, clear sky. In this way, the Earth's surface becomes very cold. When temperature of dew point is below 30 degree Fahrenheit, the moisture which condenses on solid object condenses as frost instead of dew. Then frost. When temperature of dew point is below freezing point, the dew will not condense into water drops, but it will accumulate in the form of a small white ice particle. The formation of these ice particles over extensive area is called frost. Frost is classified into two groups. These are hoarfrost and glazed frost. Then clouds. Clouds refers to a mass of small water drops or ice crystals that are formed by the condensation of water vapor in the atmosphere. Clouds are the source of all precipitation. Then types of clouds. Clouds can be classified according to their basis forms and average height of the cloud base. There are three basic forms of clouds, and these are cirrus clouds, stratus clouds, and cumulus clouds. The classification of clouds according to average height of the cloud base is high clouds, middle clouds, low clouds, and clouds of large vertical extent. Then precipitation. Precipitation is a process in which water in liquid or solid form fall to the earth. Precipitation is after the condensation of water vapor, the release of moisture in liquid or solid form is known as a precipitation. Then the forms of precipitation: rain, drizzle, snow, sleet, etc. are the forms of precipitation. About the rain, rain results from clouds when condensation has gone for sufficiently long time. Rain is the most common type of precipitation and is in the form of drops of water. Drizzle. The term drizzle is used for fine continuous rainfall, in which raindrops are very small, about 0.5 mm in diameter. Drizzle is associated with a warm front. Then the form of precipitation is a snow. Snow is a precipitation in solid form. It occurs when temperature of air is below freezing point. Snow is formed due to the freezing of drops of water. Then the sleet. Sleet means a form of precipitation containing small pellets of transparent ice. These are 5 mm or less in diameter. Thus, the sleets refer to a frozen rain. It forms when rain falling to the earth, passing through a layer of cold air and freezes. Sleet is commonly associated with showering condition in unstable air and is formed when ice particles found in close proximity. Then types of rainfall. There are different types of rainfalls are generally recognized. There are about three different types of rainfalls are generally recognized, depending on the process by which the clouds were formed, and they are convectional rainfall, orographic or relief rainfall, cyclonic or frontal rainfall. Now, the convectional rainfall. The air layers resting on the surface also gets heated due to conduction. The air expands, becomes light, and rises to higher altitude. These rising air currents are known as convectional currents. On top of the currents, condensation takes place and clouds form. Convectional currents give rise to cumulonimbus clouds, which often develop into thunderstorms and cause rainfall. This type of rainfall is associated with summer months. The convectional rainfall is received by heavy downpour and is short-lived. The clouds which are formed by this process do not cover large areas and hence rainfall is not of long duration. This type of rainfall occurs in warm and humid areas. For example, equatorial areas receive rainfall throughout the year. In the equatorial regions, constant high temperature and humidity produce this type of rainfall almost every day in the afternoon. Similarly, the tropical oceans and their adjacent coastal areas receive convectional rainfall throughout the year. Then orographic or relief rainfall. Orographic type of rainfall occurs when mountain range lies at right angle to the path of moist winds. The favorable conditions for this type of rainfall are the winds blowing from sea towards the land, should carry a large amount of moisture. Then mountain ranges should lie in the path of winds. Then the favorable condition is mountain ranges should lie close and parallel to the coast. Mountain ranges should have considerable extent and height. Orographic or relief rainfall is due to the air being forced to rise against a high mountain. This rise results in expansion and cooling of the air, which produces clouds and rain. The windward slopes of mountain alone get rain, the leeward slope being dry. The rainfall that takes place at the foot of Himalaya in India is of a relief rainfall. The rainfall that is received at Cherrapunji is also of orographic rainfall. In India, southwest monsoon winds meet Western Ghat at right angles. Thus, the western slope of the Western Ghat receive more than 300 centimeters of rainfall per year. Leeward slopes do not receive rainfall. Such areas are known as rain shadow areas. Then, cyclonic or frontal rainfall. Cyclonic type of rainfall occurs along the fronts of the cyclones and hence it is known as frontal rainfall. This type of rainfall is associated with formation of cyclonic activities, whether in the temperate regions or tropical regions. The warm and moist air masses travel along with the westerlies from the tropical areas to the temperate lands. The dry and cool air masses travel along with the easterlies from the polar areas. When these air masses of different temperatures and moisture meet, they are not mixed freely. Along the front, the temperature of warm air decreases. The lowering of temperature leads to precipitation. Due to slower ascent and cooling, precipitation in a cyclone is not violent. It is a steadily it is steady, more widespread, and is of longer duration. Then the applications of climatology in the fields of agriculture, settlement, health, trade, and transport. The application of climatology uh, in the field of agriculture. Weather and climate are important factors in determining our day-to-day and longer term activities and lifestyles. Agroclimatology helps farmers to select crops to be cultivated in their fields. The study is useful in measuring evaporation and soil moisture as it affects on plants and crops. It is useful to select appropriate crop variety and management. The study is useful in preparation of a national drought index. Then the settlement, application of climatology in the field of settlement. Humans tend to settle in areas where climate is survivable. All human settlements are in part weather dependent. Housing has to be designed to protect against adverse weather. Weather and climate play a major role in urban planning and development of new settlements. Then health. Weather has a profound effects on human health and well-being. It has been demonstrated that weather is associated with changes in birth rates, various diseases, pollution levels, etc. Air pollution and health medical climatology studies the relationship between human health and climate. Then the application of climatology in the field of trade and transport. Climate change may alter countries' comparative advantages and lead to shift in the pattern of international trade. Climate change may increase the vulnerability of the supply, transport and distribution chains upon which international trade depends. The transport weather can have multiple effects on transportation. For the example, in winter, ice blocks roads. In summer, air travel needs to watch thunderstorms, etc. The applications of climatology in different fields. Thank you.